Welcome back to the deep dive. Today we're going to unpack a real giant. We're looking at Alan Turing, and our source text for this is Philip Stokes' philosophy, The Great Thinkers.
And most people, when they hear Turing, they immediately think Bletchley Park.
Exactly. The Enigma Code, Benedict Cumberbatch in the movie. You know the story.
Sure, but Stokes makes the point that if you stop there, you're missing the big picture. Turing didn't just break a code. He kind of bequeathed the entire possibility of artificial intelligence to science.
He really did. He forced us to actually define what thinking even means. And that brings us to the famous Turing test. But what surprised me, reading the source, was the original setup.
It's not what you think, is it?
Not at all.
Yeah.
It's not some sci-fi, man in a lab coat talking to a supercomputer. It was literally a parlor game.
The imitation game, yeah. And the specifics are so important.
Right. So in his 1950 paper, Computing Machinery and Intelligence, Turing lays it out. You have three people. Player A is a man, player B is a woman, and player C is an interrogator.
And player C is in a totally separate room.
Communicating by teletype. So basically like 1950s instant messenger.
And C's job is just to figure out which is the man and which is the woman. But here's the twist. Player A, the man, is actively trying to deceive the interrogator.
And player B, the woman, is trying to help them. So you've already got deception baked into the system.
Exactly, and that is the launch pad for Turing's whole idea. He then just asks a simple question: what happens if a machine takes the place of player A?
So the machine's job isn't just to be intelligent, its job is to be the deceiver.
To be as good at pretending to be the woman as the human man was? It shifts the question completely. He gets rid of this sort of philosophical dead end. Can machines think?
Because how do you even define that?
You can't. So he replaces it with a practical test. Can a machine fool you as well as a person can?
Which opens up that huge philosophical can of worms.
Yeah.
Stokes calls it a functionalist view, which is basically if it acts like a thinking thing.
Then for all intents and purposes, it is a thinking thing.
See, I still struggle with that. The text brings up a great point. Like a child putting on a suit and imitating an adult. They can say the words, but they don't have the experience. Isn't a computer just running a very good script? Just pretending.
That's the classic objection, sure. The difference between real understanding and just simulation. But Turing would fire back, well, how do I know you're not just simulating?
The black box problem.
Exactly. I can't see what's happening inside your head. All I have to go on is your behavior, what you say, what you do. So if a machine's behavior is indistinguishable from yours, on what grounds can I say you're really thinking? And it isn't.
It's a bit unsettling. It reduces the mind to just output.
It does, and Turing was very optimistic about this. In that same paper, he predicted we'd be there by the year 2000.
Yeah, he thought a machine would pass the test, 70% of the time?
Which obviously didn't quite happen.
Stokes just puts it very dryly. Has yet to be borne out.
I mean, we're getting closer with some of the new AI models, but yeah, we missed the deadline.
Before we finish, I have to bring up a sidebar in the text that just blew my mind. We think of Turing as the computer science guy, but he also wrote The Chemical Basis of Morphogenesis.
Oh, I'm so glad you saw that. This is Turing the biologist. It's incredible.
He was using mathematics to explain why natural patterns exist, right?
Yes. Like, why do leaves arrange themselves on a stem in a certain way? Or how do you get Fibonacci spirals in a sunflower? He came up with these things called reaction diffusion equations.
And that's the math that explains how a leopard gets its spots.
Or a zebra gets its stripes. It just shows the sheer breadth of his mind. Whether it was a Nazi code, the nature of consciousness, or the pattern on a shell, he saw it all as a kind of computation.
The code underneath reality.
And that's really the final thought Stokes leaves us with. Turing's work forces us to consider that what we call thinking might just be a very, very complex form of computation.
So if we finally do build that machine that's indistinguishable from a person,
if its success rate in fooling us is no worse than a person, are we the ones who need to change our definition?
are we just clinging to an outdated sort of romantic idea of what a mind is?
Maybe. Maybe thinking isn't as special as we like to think it is.
Something to mull over. That's all we have for this deep dive. Thanks for listening.